Hi, and welcome to another video in the statistics unit. In this video, we're going to be talking about how to summarize quantitative data. Specifically, how do we describe the center of a distribution? Should we use the mean or the median or even the mode? And what standard deviation is. So let's start with the mean. The mean is a good typical value if the distribution is symmetric. And it incorporates every data point, giving each of those equal weight, right? So you have found averages before, right? You add something up, you divide by how many there are. That's exactly what we're looking at in this formula, but some new symbols to learn. The first is that we use this bar to distinguish from other variables. So this is really the average of all the y's, and that's simply the total, like we said, divided by how many things there are. But we also use this notation. It's called sigma notation. So this big sigma, it's a Greek letter sigma, is really just saying to add up all of the y's and then divide by n if there were n of them. So the mean is good in certain situations. The median is good in other situations. So the median, because it's more resistant to those extreme values, to those outliers, we typically use this if the distribution is skewed, and as you may remember from the first video, when the distribution is unimodal. A median is simply the middle of the data. The downside to the median is that it doesn't matter what the values actually are, right? So a mean, we're actually using the values themselves, adding them up, dividing by something. The median is just, think of crossing them off. They didn't even matter what they were, right? So they're very, very different ways of getting towards a typical value, which is why the distribution really matters when you're deciding between the two of these. So variation was the other topic that we said that we'd come back to. So very specifically, standard deviation is a measure of the spread. And we talked about IQR in the last video. Standard deviation is a much more powerful measure of spread because it's going to incorporate the deviation or the distance every one of the data points is from the mean. So we're not just going to average those distances together, because since there's some values will be below the mean and some will be above, it actually is going to result in 0 if we add them all up. So instead, we're going to square them. That way they all become positive, right? They will be bigger than before. Eventually we will square root them to cancel that out. But that way everything's nice and positive. We're going to add those values up, right? Like we're finding an average. And we're going to divide by n minus 1. So we're going to divide by 1 less than how many things there are. You might be wondering, well, why? Why are we going to divide by n minus 1 instead of n? You're not going to worry about it right now, okay? So when we add up all those deviations squared and divide by n minus 1, that's called variance, and we call that s squared. But we talked about how squaring them, right, is to serve the purpose of making things positive. We want to undo that. That's called the standard deviation. So once we take the square root, now we have s. So it's a process. I'd say that this is more of a process to memorize than to actually memorize the formula. So we're going to go through a whole set. So here's an example of values. So here we have 7 values. Think of those as the y's. We're going to find their mean. So if you add those up, divided by 7, you'd have that y bar. That's how we say that. Y bar is 17. Okay. So to start the process of standard deviation, we're going to find how far each of those values is from 17, right? So we're going to subtract. So each of those values, take away 17, we now have deviations, right? The -3, -4, and so on. Next up, square those deviations. So notice they're all positive now, and they are bigger. So we're going to add those up. We get 80. We're going to divide by n minus 1, so in this case 6. That is our variance. So s squared is 13.33. If we want to get to the standard deviation, let's take the square root of that. 3.65. So what this is saying is that these original values, the y's, right, their deviation from the mean is on average 3.65. Does that make sense? Let's see. 14 was -3, the deviation. Yeah, I'd say that's pretty close to the actual standard deviation. Some were a little farther away, some were a little closer, right? That standard deviation is just an average of those. So this is something that you can do. We can use this table to do, or we can even type these values into our calculator and have the calculator do it for us. And that is what we will be doing in class.